Hello and welcome back to my presentations on turning points in calculus, and in this one we're going to be looking at trigonometry functions, particularly sine and cosine. Okay, so let's have a look at this one here. We've got y equals sine 5t. Find the turning points between 0 and 1.1 seconds. So if I just page down to my next diagram, this is what I would get if I could do a decent sketch. So this would be the sketch, and you see that if I go to 1.1 seconds, which is here, there's only going to be two turning points. Of course, this is a periodic function, so it would go on forever and ever. Excuse me, and you would have an infinite number of answers to this question. So that's why we need to define it from 0 to some closing point, which we've chosen 1.1. Okay. So let's have a look. So we need, as always, when finding the turning points, we're going to make use of the differentiation, because differentiation gives us the gradient. So let's do a differentiation of this. So we've got dy over dt equals, quite easy to do this one, I'm trusting you can all do this easily. So the 5 comes out to the front, we've got a cosine function, and the stuff in the bracket stays the same. Okay, so what we're saying is, where's the gradient equal to 0? So we're going to make all this equal to 0. So we're saying 5 cosine 5t equals 0. And as we know, it's periodic, so there'd be a number of places this occurs. So let's have a look. Well, we can divide through by 5, because if I divide through by 5, that's going to cancel off that side. Divide this side by 5, because it's 0 divided by 5, it disappears. So that makes it a little bit easier. So the next step is, let's do inverse of both sides. So that will give me 5t equals 0, equals inverse of cosine of 0. Okay, so where does a cosine equal 0? Well, let's have a look. We have a look at a cosine function. Just do a little sketch of one. So if I can draw this a bit neater than I normally do. No, apparently not. Anyway, if I look at this point here, this is where my y equals 0. Excuse me. So that's pi divided by 2. And this one here is another pi on, so this is going to be 3 pi divided by 2. So a couple of values where this equals 0 and some more are pi divided by 2, 3 pi divided by 2, and so on. So adding pi every time. Okay, and so on and so forth. But we're only interested in these first two, because these two are the ones that fall in our values here, up to 1.1 seconds. Okay, right. So if I do some rearranging, so I've now got that 5t equals, basically this equals, if I take my first one here, pi divided by 2. So I've got pi divided by 2. So therefore t must equal pi divided by 10. And if I do the other one, the second figure, I would get, let's put an and in there. I don't know why my mouse has stopped working. Right, and 3 pi divided by 10, sorry. Okay, so I need to test that. Let me just shuffle up a little bit here on the board. Make myself some space. Okay, so there's my results. Problem with that is, how do I know that which one's a maximum and a minimum? And I know from my diagram, but we need to prove it. This is maths, so we're proving something here. So I need to do a double differentiation. So ft, make sure I use the right terms. So if I differentiate this up here again, to double differentiate it, I'm going to get 25. I'm going to get minus 25 sine 5t. Okay, so let's take my first value, pi divided by 10. So if I insert that into there, I'm going to get, move over here a bit, minus 25 sine 5 times pi divided by 10. I don't need a calculator for that because this is going to cancel down to pi 2, and pi 2, we know that sine is 1 plus 1, so it's going to equal minus 25. So in other words, it's a maxima. Remember, we don't care what the number is. We only care about whether it's a negative or the positive, and if it's a negative, it's a maxima. The opposite to how you initially feel it will be. Okay, let's have a look, put the other one in. I'll do it over here. Let's shuffle up a bit more, I think. Okay. So, minus 25 sine, where are we? 5 times, in brackets, 5 times 3, this is obviously going to be 15 pi divided by 10. Okay, so that would give me, if that was 15, that would divide down to 3 over 2, so that's going to be, again, I don't need a calculator, that's minus 1, so minus 1 times minus 25 will give me plus 25. And again, we don't care what the number is, we just care it's a positive. So that makes it a minima. Okay, so we've proved it there. Okay, right, let's have a look at another example. So I'll do this one fairly quickly. Same kind of thing though, let's have a look. So we've got y equals cos 3t, find the turning points between 0 and 2 seconds. So let's have a look, we'll differentiate first. So we've got dy dt would give us, so this becomes minus sine, I forgot my 3, squeeze that in there, minus sine 3t, and then I need to make that equal to 0, so let's say when. So when minus 3 sine 3t equals 0. So same thing again, I'm going to get, divide through by minus 3, so I've got sine 3t equals 0. Do the inverse of sine here, I end up with 3t equals inverse of sine. Sorry, that's 0 in there. Oops. Bear with me one sec. Clean up there. Okay. Back to 0. Okay. Okay. So sine 0, we get 0 when with 0 or pi. So it's going to be, if I put my values in here, we've got, let's do it, 3t equals pi, 0 or pi or 2 pi and so on and so forth. So that means that therefore t must equal either 0 pi divided by 3. Okay, so if I do my double differentiation, forgot my numbers, of the above term, so I've got sine would be, that's going to give me, still be minus 9 cosine 3t. So if I insert in my values, so if I put 0 in, so 0t, so 0, so when the cosine is 0, it's plus 1, so I'm going to get, so it's going to be equal plus 9. So let's write something in for that. So when t equals 0, you'll get minus 9 for the gradient. Well, that's not correct, but that's a positive value, a negative value, so it's a maxima. Why is my pen playing up? Maxima. I can't even write now. Maxima. Okay, and same way if I put in t equals pi divided by 3. Okay, if I put that into there, the 3's will cancel, so I'll just have pi. So I'm going to get a negative 1. So that's going to be plus 9. Therefore, let's have some therefores. Therefore, a minima. Minima. Okay, right, so that's my evidence there. Just a quick reminder for you all that remember we're dealing with calculus, and when we're dealing with calculus we're always in radians, so we're always in radians. So underline that for yourself. I would if I could. Right, my pen doesn't want to work. I wonder if I need a new battery. Okay, so radians always. Okay, thank you for listening.